Hey everyone, we are going to continue working in lesson 9.4. We looked at how to simplify rational expressions, but now we're going to start to do different operations with them. So today we're going to look at how to multiply and divide rational expressions. So here's what you need to know about multiplying rational expressions. And there's a couple different ways that we can do this. Sorry about that. We can either multiply then simplify, or simplify then multiply. But the process is going to look just like it did when we were multiplying fractions. And we're going to look at some examples of this. I'm going to use the second option of simplify then multiply because when we're working with polynomials, it's just going to make life easier. So what I mean by simplify first is looking top to bottom, first of all, 2/3 can't simplify, 3/8 can't, but then looking diagonally. Diagonally, I can cancel out those 3's, and then 2 goes into 8 4 times, and so this would give me 1/4. So let's just check our multiplication skills with a monomial. Keep it a little bit simple for the first one. So we've got 96 over 14n times 35n over 45. So I am going to start by looking top to bottom and seeing if I can cancel anything out. I can divide both 96 and 14 by 2. And when I do that, I'm going to get 48 and 7. Top to bottom here, I can divide both of those by 5. So I can do, by 7. So I'd get 5 and, no, I was right. I'm sorry. Divide by 5. I was having a moment. 7 and 9. Now I'm going to look diagonally. 48 and 9, well, I can divide both of those by 3. If I do 48 divided by 3, I should get 16. And then diagonally here, the 7's cancel out as well as the ends. The ends would cancel each other out. So that's a bit of a mess. But when I multiply straight across, when I look, I have 16. All of this got canceled out. So the only thing I have in the numerator is a 16. In the denominator, I look across, look across, look across. The only thing I have is that 3. So I'm going to have 16 over 3. Now, these are more like the types of problems that we're going to be dealing with. You're in luck right now because this is already in factored form. But to cancel anything out, just like we talked about yesterday, it has to be the entire expression. So I can't just cancel out the p's or just the 4's. It has to be the whole thing. So if I'm looking top to bottom, I see that I've got a p minus 4 here and a p minus 4 here, and those cancel out. Top to bottom here, there's nothing to cancel. If I check diagonally, I've just got 1's on this diagonal, and on this diagonal, there's nothing in common. Again, even though there's a p plus or p plus 6, the p cannot cancel out with either of these. So my final answer would be written like this. P plus 6 over p minus 4 and p minus 2. That would be our final answer. Now, it says to state restrictions. So this is going back to what we were doing with saying that the denominator can't equal 0. So I would just say here that p cannot equal 4 or 2. Now, some of you might see the factored form and think, oh, I need to FOIL that out. I need to multiply those together. You can if you want to, but that's being a little extra and just doing some unnecessary work. So don't worry about doing that. This would be a great final answer right here. All right, multiply the following. So when I factor the numerator of this one, what do I get? I get a minus 2 and a plus 2. When I factor the denominator of this one, what do I get? I get a plus 1 and a minus 1. Over here, I just have an a plus 1 in the numerator, and then I have a squared plus 2a. I can actually factor out a GCF there, so let's scribble that out. I can factor out a GCF of a, and I'm left with a plus 2. So looking both top to bottom and diagonally, what could I cancel out on this problem? Looking diagonally, I can cancel out a couple of things. I can cancel out the a plus 1's, and I can cancel out the a plus 2's. So what I'm left with in the numerator is a minus 2. And in the denominator, I have an a times a minus 1. But I still need to state my restrictions. So looking at the denominator, I'm going to look at all of the pieces of the denominator. So going back to the factored form of each one, even though these canceled out, I should still state these restrictions, because if I, for example, like I have a equals -1, even though this factor canceled out, because if I were to still go back to the original problem and plug in -1, it would still give me something over 0. So I'd have -1, +1, 0, and -2. Those would be my restrictions, so that a cannot equal those values. All right, try this one. Go ahead and multiply them together, and then go ahead and state the restrictions. All right, so this is what it should look like when you factor it. Please ignore the scribble there. I made a small mistake. So we get 7n over this. GCFs are important. Got to check for them. And then I canceled out 7n's and 3n minus 8, and I was left with this. And then my restrictions are, if I just kind of work left to right, and I started here and said n cannot equal 0. And even though that's a squared and then it happens again over here, I don't need to write that each time. Once it happens once, it's just there. So it cannot equal 0 or 8/3. All right. Now let's talk about dividing. So using what we remember about dividing fractions, there are two things that we have to do. The first is to change the divide to a multiply, and then write the reciprocal of the rational expression that comes after the division sign. So if I'm dividing these two fractions, 2/3 and 4/5, instead of saying divide them, I'm going to change that divide to a multiply, but then I have to flip that second fraction. So it's going to become 5/4. And now I can cancel out or simplify, and I'm left with 5/6. So ours are going to be slightly complicated, or just because we're dealing with rational expressions, but that's the same idea. It's the same process for multiplying and dividing as it is with the rational expressions as it is for fractions. So I have 10m over 9. I'm going to go ahead and flip that second fraction. I've got over 15, or 15, sorry, over 13m squared. Now, top to bottom, I don't see anything on either of those that I can simplify, but diagonally, I can divide both of these by 3. That'll give me 5 and 3. All right, and on the other diagonal, I can't simplify the 10 and the 13, but hey, there's an m here and an m squared here. So this m goes away, and the squared part goes away. I'm left with just one m left. So multiplying those together, I'm going to get 50 over 3 times 13 is 39m. And I like to simplify first, but it's still a good habit to look at the end and make sure that you can't simplify any further. If you get to the end and you can divide them both by 2, it just means that maybe you missed something, okay? So now we need to state the restrictions. So I know my denominator, so I've got to look at 3, and so I can't have a 0 here. But when we're dividing, there's actually 3 parts we need to look at: denominator 1, denominator 2, and numerator number 2. Why do you think this part matters with divide instead of multiply? If I plugged in a 0 right here, I would have 0 for the whole thing. However, I would then be dividing this by 0, and that doesn't work. So if I have we know that that can't work because I can't divide by an undefined value. But then even if those two are switched, I would still be saying 2/3 divided by 0. So that's why I have to look at, let me get out a highlighter, see if this works. I have to look at 3 pieces for my restrictions when dividing. Only when dividing, not when multiplying. All right, a couple more. So there we go. We are going to rewrite this. All right, so now it's a multiply problem. So go ahead and simplify that and see what you get. All right, so this is kind of messy. I just crossed this out and factored it. I factored out the GCF of 8 and had n minus 6 left over. These diagonals cancel. N minus 6, n minus 6 cancel. And so all I'm left with on this problem is just 8. So my restrictions would be anything that make this be 0. So this, to make that 0, would have to mean that n cannot equal 6. Over here, this would also be an n cannot equal 6. So is this one factored? I don't need to write it again though. And up here, this would tell me that n cannot equal 0. So that would be the whole problem. All right. Go ahead and try this one all yourself from the beginning to end, and then we'll check and compare our answers. All right, so you should have gotten this for an answer. I flipped the second fraction, or flipped the second reciprocal function, crossed out the x plus 2's, crossed out x plus 4's, and I'm left with just x plus 8. For my restrictions, I would say that x cannot equal -4, -2, and then the -4 happens again. But that does not need to be restated. All right, last one. And this is about as challenging of a problem as I will ever give you. All right, there's a lot happening here, starting with some GCFs. So I'm going to do this kind of off to the side here. I'm going to factor out, I can factor out a 2 for that. So I'm going to have 2 times 5b squared plus 21b plus 18 all over. Here I can factor out a 2 as well, and that would leave me with 3b squared minus b minus, what did I factor out 2? Minus 30. Okay, so over here, even before I rewrite it as a times, I'm going to go ahead and factor it. Here I can factor out an 8, and I'm left with 5b plus 6. I can't factor out a GCF there, so that one just stays. All right, now, this one, the reason it is just complicated is because you've got several quadratics to factor. So factor each of these and see what you get. Okay, forgive the mess, but there was a lot of work to show. So when I factored out this trinomial, I got 3b minus 10 and b minus 1. When I factored this one, I've got 2 times 3b minus 10, b plus 3. And when I factored this one here, I got b plus 3, 5b plus 6. So just doing some quick canceling, I go like this and cancel those. 3b minus 10, this is the best part of the whole problem. b plus 3 cancels, and my 2's actually cancel. So after all of that, I'm left with just b minus 1 over 8. My final step will be to determine what are the restrictions. So I'm going to look through each of my factors in the denominator of the first function and the numerator and denominator of the second one. So here, 2 is not going to change anything. If I set 2 equal to 0, it's just a not true statement. So if I do this one, I get that b cannot equal 10 over 3. Here I would get b does not equal -3. Here this gives me b cannot equal -6/5. I have the 10/3 again, which I don't need to write a second time. But then I also have b cannot equal to 1. So this one had 4 restrictions, but I mean, when you look at how many factors it had, that kind of makes sense. So that is multiplying and dividing with reciprocal functions, or rational functions, excuse me. If you have any questions, make sure and let me know.